Good morning, grade 8 learners. Welcome to Grade 8 Science Valenzuela Live, where learning science is fun and exciting. I am Sir V at your service from Vicente P. Trinidad National High School. Today, we will be exploring the wonders of electricity. At the end of discussing this topic, we should be able to infer the relationship between current and voltage. Last week, we learned how to define electric charge, how to differentiate between static electricity and current electricity, and how to infer the relationship between current and charge. For the second session related to electricity, we shall do the following. First, we are going to define voltage, current, and resistance. Second, we shall discuss the relationship between current and voltage and resistance in an electrical circuit. And third, we shall solve word problems related to Ohm's law. Before we start, please prepare the following materials: your pen, your notebook, your calculator, and your learner's module in science. If you are ready, then let's get started. Last session, the term electricity is the focus. In the comment section, type a word or a phrase that is somewhat related to what you have learned about electricity. Okay, recall the things that we have discussed last session regarding electricity. I have introduced you to a lot of terms. So type just one word or just one phrase that you remembered about our discussion last week. Type it in the comment section. Okay, right now I am seeing several words that you type in the comment section. Now, I can see that there are a lot of terms that you have mentioned. And because of that, I can also see that you have learned from the previous session. And I am happy for that. So, from all the terms that you mentioned, the most important thing about electricity is that it is related to the charge or electrical charge. Also, during our previous session, we mentioned three important measurements related to electricity. So they are represented by the three letters I, V, and R. Concerning today's topic, what do you think are the meanings of these three letters? You may type the answers in the comment section. Again, we have three letters here: I, V, and R, which is somewhat related to what we are going to talk about today. The correct answers are: I stands for current, while V stands for voltage, and R stands for resistance. So we are going to talk about these three measurable properties related to electricity. In the previous session, we already talked about electric current. We learned that electric current or current is the measurement of the flow of charged particles per second, which is represented by the SI unit, amperes. Now, let's continue by discussing what voltage and resistance are. Voltage is defined as the amount of work needed per unit charge to move charged particles from one point to another. Voltage is also known by several terms such as electric potential difference, electric pressure, and electromotive force. For us to easily remember what voltage is, we can say that voltage serves as the push that causes charged particles to move in a wire or other electric conductor. Voltage is one of the main reasons why electricity is hazardous when not handled with extra care. The SI unit for voltage is volts. Volts is derived from the unit joules per coulomb. Volts is named after the Italian physicist Alessandro Volta, who is credited as the inventor of the electric battery. Voltage can be measured using a voltmeter. Another electrical property that we must understand is electrical resistance, or simply called resistance. Resistance is the measure of the difficulty of passing an electric current through a substance. The SI or standard unit for resistance is ohm, which uses the Greek letter omega as its symbol. The unit ohm is named in honor of the German physicist George Simon Ohm. Resistance can be measured using an ohmmeter. There is more to George Simon Ohm than naming the unit of electrical resistance after him. He published a book that described one of the most important quantitative descriptions of the properties of electricity. This led to the establishment of the statement currently known as Ohm's law. Ohm's law states the relationship between three electrical properties: current, voltage, and resistance. It is expressed using this formula. Current equals voltage divided by resistance. In this formula, electrical current uses the unit amperes. Voltage uses the unit volts. And resistance uses the unit ohms. We will be using circuit diagrams and a simulator to visualize the relationship between current, voltage, and resistance. On the top left side of the screen, you can see three letters that represents Ohm's law. On the top right side, there are sliders where I can adjust the levels of voltage and resistance. And at the bottom, you will see a circuit diagram composed of an electrical source, a magnified view of the charged particles, and connecting wires that shows the direction of the current flow. Now, according to Ohm's law, the electric current flowing in a circuit is directly proportional to the applied voltage. So, what happens to electric current if voltage increases? Will the magnitude of the current increase or decrease? Write your answer in the comment section. Again, observe the simulation that is happening right now. So again, what will happen to the current if voltage increases? Will it increase or decrease? So, if your answer is current increases as voltage increases, you got the correct answer. Also, Ohm's law states that electric current flowing in a circuit is inversely proportional to the resistance of the circuit. So, what happens to the current if the resistance decreases? Will the current increase or decrease its magnitude? Write your answer in the comment section. Again, what will happen to current if the resistance decreases? Will the current increase or decrease? So if you answer that current increases as the resistance decreases, you got the correct answer. So remember that the relationships I mentioned a while ago apply under Ohm's law, provided that temperature remains constant or it does not change. Now, let's proceed to solving word problems related to Ohm's law. On the screen, we can see the three Ohm's law quantities that are placed inside an equation triangle so that we can easily derive formulas as needed. V is at the top, then I and R are located from left to right bottom portions. You can write this equation triangle in your notebook so that you can remember. Now, what we are going to do next is we try to cover letter I from your side using your finger. But do not touch your gadgets or your gadget screen. Just block letter I from your side using your finger. Now, by blocking letter I, we assume that the missing quantity for a specific word problem is current or letter I. Now, by using the equation triangle, we identify that the formula for current is voltage divided by resistance, or V divided by R. Now, try to block letter R from your side, again using your finger. What is the formula for electric resistance? Again, if the missing quantity is electric resistance, what will be the formula? Write your answer in the comment section. Again, resistance is the missing quantity. So, how are you going to compute for electrical resistance? Now, if your answer is resistance is equals to voltage divided by electric current, you got the correct answer. Or V divided by I. Now, cover letter V from your side using your finger. So let's have letter V. Now, what will be the formula for voltage? Write your answer in the comment section. This time, we are assuming that V or voltage is the unit or the value to be computed. So what would be the formula? Again, using the equation triangle, we identify that the formula for voltage is current multiplied by resistance, or V is equals to I times R. Now, as seen on the board, there are three formulas related to Ohm's law. Use any of the three formulas depending on the missing quantity of a specific word problem. What we are going to do next is to solve a given problem set for today's session. So we shall follow the basic procedures in solving these problems. You may write your solutions in your notebook, then type the final answer with the correct unit of measurement in the comment section. So make sure that your final answers are complete. So the numerical value and the unit, the correct unit. Okay? So if you're ready, then let's begin. Here is the first problem. A 220 volt wall outlet supplies power to a lamp with a resistance of 2,200 ohms. How much current is flowing through the lamp? Now, let's analyze this problem by listing the quantities first. So the quantities for this problem are the following. First, 220 volts, which represents voltage, and 2,200 ohms, which represents resistance. The value to be computed is the current. Okay? So using the equation triangle, which formula shall be used for the problem? Correct. The formula to be used is I is equals to V divided by R. Now, substituting the values, we will have I is equals to 220 volts divided by 2,200 ohms. Now, using your calculators, what would be the final answer? Again, the formula is 220 divided by 2,200. Type your answers in the comment section. Again, the correct numerical value and the correct unit. So, the final answer shall be the current is equals to 0.1 amperes. I hope you got the correct answer. Now, let's proceed to the second word problem. For the second problem, a radio with a resistance of 40 ohms has a current of 0.1 amperes flowing through it. How much voltage supply the radio? Again, a radio with a resistance of 40 ohms has a current of 0.1 amperes flowing through it. How much voltage supply the radio? So we can see that the given quantities in the problem are, first, 40 ohms, which represents resistance, and 0.1 amperes, which represents current. So the missing quantity for this problem is voltage. So we are going to determine the formula for voltage using the equation triangle. What is the formula? How are we going to compute for the voltage? Have you identified it already? Correct. Voltage is equals to I times R, or current times resistance. Now, substituting the values from this formula, we shall have the solution V is equals to 0.1 amperes times 40 ohms. What would be the final answer? Write your answer in the comment section. Again, correct numerical value and the correct unit. Do not forget the unit, it's also important. If you answered voltage is equals to 4 volts, got the correct answer. Now, for the third problem, let's try to solve the problem on your own. I will give you enough time to solve the problem. You can start solving while I'm reading the word problem. Are you ready? Let's go! For our third problem, a 250 volts power source supplies an electrical appliance that possesses 5 ohms of electrical resistance. How much current is flowing through the circuit? Again, a 250 volts power source supplies an electrical appliance that possesses a 5 ohms of electrical resistance. The question is, how much current is flowing through the circuit? Type your final answer in the comment section. Again, you should state first the given. So, what are the given quantities in the following problem? Then, identify what is the value or the measurement to be computed. So, if If you determined that already, so go back to the equation triangle, then identify what formula shall be used. Then you're already substituting the values, and you can now solve. You can use your calculators for you to solve the final answer. Again, do not forget in typing your answer correct, numerical value plus the correct unit. Okay, time's up. Let me show you the list of quantities first. So we have voltage is equals to 250 volts, while resistance is equals to 5 ohms. The unit to be computed is current, okay? Or the value to be computed is current. So the formula for current is I is equals to V divided by R. So substituting the values, we shall have I is equals to 250 volts divided by 5 ohms. The final answer shall be 50 amperes. So I've seen that you have done well in solving several word problems related to Ohm's law. Keep it up. Remember that if ever you have difficulty in solving this kind of word problems, you can always go back to analyzing the problem using the equation triangle. You can also ask help from your science teachers, and you can even type your questions in the comment section, and I'll be gladly helping you. Now that you have learned a lot for today's session, let's have a recap of the most important points to remember. First, current is the measure of the flow of charged particles in an electroconductor. Second, voltage is the measure of the push that causes charged particles to move in a wire or an electroconductor. Third, resistance is the measure of the difficulty of passing an electric current through a substance. Fourth, Ohm's law states that current is directly proportional to voltage and inversely proportional to resistance. Lastly, Ohm's law is essential in analyzing electrical circuits and in emphasizing the importance of practicing electrical safety. Now, let's answer some of your questions. Let me have my set of questions. Thank you, sir. So let me look first at some questions that several of you sent me right now. So let's choose one that we can answer today. Okay, this would do. Let me read the question first. Good morning, sir. Tanong ko lang po, which is more dangerous? High current or high voltage? Thank you for that question. So, my answer for that question is high current is dangerous because it can cause chemical changes in the body cells, and it can also stop the functioning of the heart. Now, but remember that human skin is a poor electroconductor, so this high current value won't do much effect on the human body unless there would be a high voltage level that will push these charged particles through the skin. So if you're going to ask me how much voltage is fatal to human body, I can say that it takes more than 40 volts. 40 volts to push a large current of electric charged particles, that is enough to become life-threatening. So remember the voltage, 40 volts. So more than 40 volts or more, that's already fatal. Again, to be fatal to human body, the power supply voltage must be higher than 40 volts and the current rating must be 10 milliamperes. But it's more important to remember to always practice caution in handling electric objects. this regarding the whether it is high voltage or high current, better be safe than sorry. So that's the important thing. So I hope that I have answered your question. Let's proceed to another question. So let me search for some questions here, and okay, we can answer this. Good morning po. Why can birds land on electrical power lines without getting electrocuted? Okay, so I think we can answer that. Thank you for that question. Electric charges always look for the shortest possible path. They would rather go straight through the wire or rather than taking a detour. So they prefer the shortest path, or we can say the shortcut. Bird skin may be a conductor, but it is less conductive compared to the copper wires that makes the power line. So there is a very little chance the bird will get electrocuted if it touches the power lines. I hope I have answered your question. So if there are other questions that you want to ask, feel free to ask by typing your questions in the comment section. I'll be gladly answering your questions. That ends our session. See you next week for another episode of Grade 8 Science Valenzuela Live. Again, anuman ang sitwasyon, tuloy ang edukasyon. Stay safe and have a great day.